Hi, welcome. Today, we are diving into the next generation robotics, exploring how cutting edge machines are revolutionizing industries, enhancing lives, and shaping the future. Right? So, by the way, I am Kit Steven Banchala from the MSIT. Okay, let's get started. Do you know the meaning of the robot or the word robot? So, etymologically, the term comes from the Czech word robota, meaning forced labor. So, it was used for the first time 100 years ago now, in a play by the author of the same nationality, Karel Capek. So, he is the author, which is Karel Capek, the author of the word robot. To talk about the origin of robotics, we must mention Aristotle and his ideas about automated tools, Henry Ford, Leonardo da Vinci, and his mechanical knight, or his Isaac Asimov. So, on the other hand, the word robotics was employed for the first time by Isaac Asimov of 1920 to 1992 in his novel Ran Around 1942. So, contained the famous series I, Robot. In that novel, he defined three rules of concerning the behavior of robots and the interaction with humans. So, these rules would later be named the three laws of robotics by Isaac Asimov of 1942. Alright, what is robotics? So, from the word robotics, we have the acronym or the word robot. Robotics refers to the design, creation, and application of robots, machines capable of performing tasks autonomously or semi-autonomously. So often mimicking human actions and or augmenting capabilities. So that's what robotics means. So it refers to a design or creation. So from the pictures above and beside, we have the examples of robots. So it is a design, a creation, and application of robots. So it is a machine which is capable of performing tasks. Next, the evolution of robotics. Okay, next we have the evolution of robots or the robotics. So from the first generation robots, we have 1950s to 1970s. So robots are simple, pre-programmed industrial machines for repetitive tasks. So some of the robots are just simple robot, which is programmed industrial machines for repetitive tasks. The second generation robots we have on 1980s to 1990s. So in this second generation, we have the integration of basic sensors. So the robots have already its sensors, enabling limited feedback and adaptability. Alright? So the second generation is more on advanced than the first generation robots. Next, in the modern robotics, we have the 2000s up to the present times or now today. So advanced robots with AI. So some of the robots are already with AI or artificial intelligence. Mobility and real-time data processing, capable of dynamic decision making, right? So in the modern robots or in the modern robotics, these are the robots with advanced or with AI or artificial intelligence. Then there is also the mobility, the real-time data processing, and capable of dynamic decision making. So there are lots of decision making. Next, so the key advancements enabling next-gen robotics. So what are the key advancements? So what are the key or the advancement of these robotics or the next generation robotics. So first we have the AI, or the artificial intelligence. So it enhances decision making, learning, and autonomy in robots. So it enhances decision making. So it helps you in the decision making, in learning process, and in autonomy. All right. Next is the Internet of Things, or IoT. As we all know that it is very popular as of this generation. We have it enables connectivity between robots, devices, and cloud systems for data sharing and remote control. Alright, next, the third key advancement is the advanced materials. So from the word advance, of materials. So innovations like lightweight composites, flexible materials, and self-healing structures allow more durable and adaptive robots. So from the materials being used of a robot, so there are many innovations, like the robots are already in a lightweight composites, flexible materials being used, and the self-healing structures, which is it allows us for more durable, or it allows the robot for more durable and adaptive robots. Next is the current state of robotics. So what are the current state of robotics? So robotics has evolved significantly over the past few decades, transitioning from simple pre-programmed machines to sophisticated systems capable of performing complex tasks. So the current state of robotics reflects both remarkable achievements and ongoing challenges as robots integrate into various sectors. So from the word robotics, the current state of robotics is evolving significantly over the past few decades. So it is evolving significantly. Next is the applications of robotics. So there are many applications of robotics. So where can we apply robotics or robots? So first is on the manufacturing. So robots dominate manufacturing floors, performing tasks like welding, assembly, and quality inspection. Alright, so in manufacturing, robots are already dominant in the manufacturing floors. For example, the robots are already on skills of welding or assembling components or materials, and quality inspection. So what are the impact of manufacturing? Increased efficiency. So it will increase the efficiency, or be very efficient where is the manufacturing it is, or the precision, or it is precise, and scalability in production process. So it increases efficiency. So it is very efficient and precise and scalable also in the production process of the manufactured products or materials. So for example, robotic arms by companies like FANUC or the ABB streamline automotive and electronics manufacturing. So robotic arms by companies like FANUC or the FANUC and ABB streamline automotive and electronics manufacturing. So some of the automotive company or manufacturing are using robots. Alright. Next application is the healthcare. So robots assist in surgeries, patient care, diagnostics, and rehabilitations. So some of the robots are already like doctors. So doctor robots. So some of the doctors are already robots, diba? So robots assist in surgeries. Some of the doctors or the robots are already in surgeries, patient care, diagnostics, and rehabilitation. So what are the impact of healthcare of robotics? So enhanced precision in surgeries, reduce recovery times, and improve patient outcomes. So it will reduce your recovery time. So for example is the Vinci surgical system for minimally invasive surgeries and robotic exoskeletons for physical therapy. So it is a Chinese general hospital and medical center now offers robotic assisted surgery. So in the Chinese General Hospital and Medical Center, they have their own robotic or the assisted surgery. So it is called the Vinci surgical system. Alright? Next is the logistics and supply chain. So robots automate warehouse, precision operations, package handling, and delivery systems. So what is its impact? Faster order fulfillment, reduce errors, and lower operational costs. So it will It will be more faster when using the robotics in delivery and in packaging unit. Next is some examples ani. We have the Amazon's robotic system for inventory management and autonomous delivery robots like Starship. So here is an example of the autonomous delivery robots, which is the Starship. So Amazon's robotic system. So they are using robots for their inventory management and for their autonomous delivery. So what we call that as the Starship robots. Next is the agriculture. So robots monitor crops, automate harvesting, and analyze soil condition. Impact niya, we have to improve yield and reduce labor dependency. So it will improve your yield and the labor dependency it will reduce. Drones for crop monitoring and robotic harvesters for fruits and vegetables. So there are many robots as of this generation. They are using robots in their harvest and their crop monitoring. So drones are examples of robots for the crop monitoring. Alright. Next is the space exploration. So robots play a critical role in exploring extraterrestrial environments and maintaining satellites. So what is its impact? We have expands the scope of space missions and ensures human safety. Examples: Mars rovers like Perseverance and robotic arms on the International Space Station. So some of the space exploration, so they are sending robots as of they are exploring the extraterrestrial environment. For example, on the Mars, so they are sending robots in the International Space Station. So they are not only sending people or a person for space visit exploration or the visitation, they are also using the robots for space exploration. Next is the limitations of today's robots. So what are the limitations? We have here the technical challenges, cost constraints, ethical and social concerns, physical and functional limitations. Alright, so what is the emerging applications? We have the healthcare, which is the surgical robots, elder care, and rehabilitation. So in the pictures beside, we have here the surgical robots. So it operates surgical robots by the surgery of the people. Alright, next is the emerging applications of agriculture, which is the automated farming. So as what I have discussed A while ago, we have the precision agriculture, automated harvesting, and soil management. So that is the emerging applications of robotics. Next is the transportation autonomous vehicles. So self-driving cars. So as we can see on the picture, we have the self-driving cars. The drones for logistics. So that was called the Starship as well a while ago. So that is an example of drones, which is delivering your logistics. Next is the public transport automation, which is all about the transportation. Next, number 4 is the space exploration and personal or domestic robots. So there are space exploration in the pictures. We have the robots. We have the personal domestic robots. We have here cleaning their house or their home, and disaster recovery. Next is the trends and challenges. What are the trends and challenges? So soft robotics. We have the swarm robotics and cloud systems. So they are using cloud systems, swarm robotics and soft robotics. So challenges. We have the ethics, so ethics, safety, employment impact, and regulations. Those are the challenges. Next is the future outlook. Robotics in the Industry 5.0. A human-centric approach, personalization, human-robot synergy, and sustainability. So, a human-centric approach. It means that robots are in human-centric. So, these are all humans approach. So here is the examples of a human approach, human-centric approach. Next is robotics in society, shaping everyday life, healthcare transformation, smart cities, accessible living, education, and creativity. So that would be the possible robotics in the 5.0 generation or society. Now, how will robots reshape work and society? So, we have the workforce transformation and social impacts and challenges. So, what will be the reshape work and society? So, automotive and repetitive tasks, automation of repetitive tasks, reskilling and new jobs, cobots and workspaces. Okay? Then the societal impacts and challenges. So what ethical measures are needed for robotics? So ethical guidelines and governance, safety and reliability, regulation and accountability, social considerations. So that would be the ethical measures are needed for robotics. We have the ethical guidelines and governance, the safety and reliability. It is very reliable for us, or it is very safe for us, and regulation and accountability and social consideration. Now, we have now in the conclusion part. So, as we all know, robotics is poised to transform industries, reshape workforces, and enhance everyday life through advancement in automation, collaboration, and intelligence. So key technologies such as an AI or the artificial intelligence, soft robotics, and cloud systems are driving this progress, enabling applications from healthcare and agriculture to transportation and space exploration. However, these developments come with challenges, including ethical dilemmas, safety concerns, employment impacts, and regulatory needs. So, the promise of Industry 5.0 lies in achieving a human-centric approach where robots complement human creativity and decision-making while promoting sustainability and inclusivity. That would be all for today. Thank you for listening.